My pleasure to be here today. Given it's not a huge group, if you guys want to shout out questions or comments or challenges, I'd love it to be interactive because it will make it more fun for me and hopefully more valuable for you along this road. Um, so um, I had been retired after Pure Storage. We had the great success of building a public company. Um, and I started playing around with LLMs, and I actually got excited. Um, Most software sucks, and it's extremely hard to craft and evolve. I worked with these fantastic engineering teams that made this Herculean effort to build this deeply complicated software that ran storage systems, ran application servers, and so on. And it was excruciatingly painful, to get that team all on the same page and building in the right direction and delivering consistent architecture and security and reliability. I did not understand how hard software was at university, and it was a wake up call that there was so much pain to create great software. We see problems across the boards. Last year, in the U.S. economy lost $2.5 trillion due to software failures. Globally, I think the cybercrime footprint is $10 trillion of wasted investment. We only invest $1 trillion in software engineering salaries, but we lose $10 trillion on security. So what if we could pay down all of the software debt? What if we could, create the software of our dreams? So this is what I came to with this idea around seeing LLMs and thinking they might be a great complement for human intelligence. We called the company Augment because we don't believe we're anywhere close to, computers taking over and doing all of the software development tasks, but that we wanted to complement human developers and make them more productive. I'm especially struck, like, all software aspires to be legacy, right? That's the best outcome that software can have. But unfortunately, as software becomes legacy, it generally gets ossified and locked into particular platforms. And often the tests are no longer there. So developers are too scared to change anything because their fear of unattended consequences and that they're going to break something. Perhaps AIs can rewrite the tests and then understand these legacy systems. I mean, we're nowhere close to this yet, but be able to inject new life into them as well. So I see so many targets. I mean, literally every week I use a piece of software that pisses me off, right? That it just behaves in a way that I think it shouldn't behave. To me, it's obvious that this software could be better. So there's the hope, the dream that we can indeed make it better. But of course, this is an extremely difficult problem. Software doesn't, it's very abstract, and the data that it works against is abstract. None of it conforms to the laws of physics. So we have a difficult reasoning problem in trying to figure out what to do. LLMs are making amazing progress. There was a case recently of Anthropic Claude finding a race condition that had been in the code for many years, but a seemingly unrelated change had tickled this race condition, and that fix had eluded the top architects on the project for months. And then Claude found it. I don't think Claude was, had advanced so far in its reasoning ability that it understood the abstract model, but I do think it got to see so many other fixes to problems that it was able to pattern match and find an error that others weren't able to look at. So it's becoming an increasingly critical tool in the tool chest. Again, this is obvious. Software is just hard. I remember being struck in Y2K, so I'm showing my age here, that I've been doing this for a long time. By the way, funny aside, Mark had mentioned that my tenure at WebLogic and BEA Systems, someone saw my name in the context of Augment and recognized it from BEA and said, "Oh, is that your dad?" Like, there's no way that you could still be relevant and doing some interesting work given you were active 20 years ago. Um, so back to this problem, the Y2K thing that stunned me was we didn't know what was going to happen, right? When you have these complex interconnected systems, it's really hard to reason about how they're going to behave in the face of change. So if we can get some help along the way from AI, I think it's a great thing, especially as you look at the challenge of managing diverse, distributed teams that all have different perspective, different orientation. Maybe they work in different time zones. It's really difficult to get a consistently excellent architecture out of that. So AI is the hot new thing. Developers are really keen to have it, but I would say the return on investment case is still a work in progress. We get asked this by customers all the time. The reality is engineers are an empowered lot. So when they are excited to try something, they have a lot of leverage to get it brought in. We've been anecdotally collecting data about how much AI is really helping, but it hasn't been very systematic as of yet. So I think people are right to be skeptical and want to see the proof points. Across the engineering team at Augment, we do see things like 2x productivity improvement, and this is perceived rather than measured, so take it with a grain of salt, for just simple coding, like tasks where I'm going through and wanting to do something. One of the capabilities that we added was a next edit. So we build a special model that looks at the work you're doing and then tries to infer where you're going next. Like if you add a field to a data structure, then it'll take you on a tour of where that data structure is persisted, where it's passed across the network, so that you can make all of the associated changes. That turns out to be incredibly helpful, right? How many times you get interrupted in the middle of a complex change, and then you're trying to go back and say, okay, where was I? How far through this process? And pulling that thread and swapping it back in, it's really great if the AI can help you to do that. Better productivity on unfamiliar code. This is one of the big things that people tout. One of our customers, Webflow, when they first installed Augment, they had an aggressive mentoring program because they have turnover like most organizations do in their engineering program. And the chief architect tried something one day when a new dev came in and asked him a question. He typed, because he and probably, he said, a handful of other architects on the project would have known that answer. He asked the question of Augment, and Augment spit out the answer. And that piqued his curiosity, so he continued. And he started, he built his own little quiz of the things that only he and the top most senior engineers on the project knew, and Augment was generally able to answer all of them. So he's like, we can let go of our mentoring program. We no longer need to load up our senior devs with the same workload in helping new devs come on board, because the AI can really help that happen much, much more quickly. One customer that was a lot more systematic measured an 80% return in how quickly a ticket was resolved and how often a pull request had to be revisited. So 80% return relative to no AI, and that was across hundreds of engineers over a period of months, so a little bit more systematic. Maybe though the most interesting change that I've seen is people moving from traditional programming to what I'm calling meta programming. It's now a point of pride at Augment with our agents that you try not to write code yourself. You try to prompt the agent to deliver all of the code. So you spend your time crafting the prompts and ideas that then lead the agent to particular outcomes. And you might spin up 3 or 4 agents in parallel and race them and try different approaches, but you act more like a referee than the direct programmer. And we see, this is really a spectrum. We have plenty of engineers that still want to get in and change the code, but some that I would say, devote extra energy not to do that. They want to live and work through the agent rather than doing it themselves. It is getting better. This is startup data from a mutual customer. So the company is called Milestone. It's an Israeli startup. They actually measure by plugging into Git a bunch of data about turnaround times on tickets. So they're measuring rough complexity of the fix. They're measuring whether there are bugs in it and it has to be revisited, and then time to turn it around. And this particular one benchmarks augment versus no AI, but they actually have similar analyses that they're doing, because some customers want to race augment versus Copilot versus Cursor versus Windsurf versus Cognition, Claude Code, the full spectrum of players in the market. So I think we'll get a lot better at getting this data over time. So as we talk to lots of companies about what's going on out in the marketplace, I would say there's two broad approaches is how people look at AI, assuming there is indeed the productivity boost that I claim is arriving. How are you going to spend it? And I broadly lump people into the private equity players that say, we think our software is fine, we're just going to cut costs and deliver kind of the same software with less resource. I think that's an unenlightened view for most businesses. I'm much more excited about the organizations that want to invest and deliver all of the software of their dreams, right? That goes back to the vision statement from earlier. And then my hope is we'll actually see a renaissance in software engineering. As projects become more predictable, as the outcomes become better, people will take on more software engineering exercises. They'll take legacy apps and they'll move them to the cloud. They'll take software that they'd like to have, nice to have, and decide to actually build it. Obviously, this is still TBD, but certainly very curious to watch how this shakes out.
Yeah.
So this goes back to the original title. Abundance is a fun word in talking about generating wealth and across society. I would love to think that we can get to software abundance, that we can finally have software that doesn't piss me off and piss you off, and it doesn't get broken into, and it doesn't break, it doesn't cause data corruptions. I mean, what are we going to be capable of delivering to humanity if we are able to crack this nut and be able to deliver all of the software that we would like to have in the world? Andrew Karpathy is written about this a bit. I don't think it's been discussed a lot, but he talks about the software architecture is changing. We're actually imbuing our programs with agency. We're making them more self-sufficient, more adaptable, more flexible. Like if you think about a traditional code embodying a fixed workflow, by embedding AI technology models into our applications, we can give them more self-sufficiency to drive outcomes rather than just do exactly what they're specified. And we are seeing this now as agents call other agents. Maybe they're sub-agents where they're assigning a particular task in a broader flow. It turns out that's really important to get productivity out of agents, is to give them work that is of the right size so they are able to accomplish their task. But I think it's also going to include agents calling other agents across organizational boundaries to get work done. And that we may see much more interaction, I'm convinced we will see much more interaction between AIs than we will between sort of traditional software. Didn't mention this, but agents already can call regular software routines. This is the tooling interface of the model context protocol that Anthropic came up with, but it's being used very broadly. Obviously, that presents a bunch of security challenges along with it. You guys are deeper on this than I am, but I will offer a couple of thoughts on security coming up. So I think there's some good news around AI and security. One of the things that we really strive to do is to leverage the best practices that are in your existing code base. So augment, and I think our competitors are either doing this today or will be doing this, look at what are your security policies inside of your code and try to mimic it. We'll even use recency as a signal. So if you're moving away from one security architecture to a new architecture, we'll look at that history and say, directionally the code is going this way. I should prefer this newer approach to security over what is already there in the code. And there are plenty of other places to get signals. We mine information from Notion documents, from Slack messages, being able to or code reviews. Being able to incorporate that knowledge hopefully leads us to better outcomes in the software. Another innovation that we've delivered is, we call it memories. And it's when you're using an agent, you can give it guidance and capture your policies and best practices in those memories, and they can be shared across developers. So you can set global security policies that are included in the prompts that are passed to the AI models that are ultimately generating code, and it's a way of getting passwords out of programs, for example. One other area to pay attention to is AIs can leak intellectual property. So one of the things that we did was we require proof of possession for the AI to be informed with a particular piece of software. So if there is software that is, say, under a tighter security umbrella, if I don't have access to that code, then the AI that's working with me has no knowledge of that code, hasn't seen it, can't help me use it. So in this way, AI can't leak information about how security is handled if it's being more tightly held. I think we're the only ones that do this today, but it certainly seems like a critical practice to us. And I want to mention an aside, the AI community in general has been fast and loose with intellectual property, I think in a really unhealthy way. We have competitors that have defaulted users into allowing training on their code. So in that situation, if you just install their IDE plugin without even saying yes, they upload your code to the cloud and they infer that they have the rights to sell that code to third parties for model training. And that is a huge breach of any sort of reasonable behavior, presumably is illegal as well. So I think there's going to be a lot of scrutiny paid in the months and years ahead to how AIs are treating your intellectual property. We never sell code to third parties. If you do allow training, it's only for internal use at Augment. And we encourage people that aren't open source to developers to be very careful about allowing such training. I think that's a much better practice. Any questions so far?
So when you talk about using the code for, are you talking about for training it or for like, RAG type of stuff or, that kind of thing?
Good distinction. So I'll talk a little bit in a few minutes about how the Augment architecture works, but we do take your code up to the cloud and we build a semantic model of it that we use for RAG, and that's how the AI is informed on your code. But we do not train on that code ever, unless it's open source and you've explicitly given us permission to do so. So RAG itself doesn't leak any intellectual property. As long as the implementation is done properly.
So I think it's great that you're concerned about the sensitivity of the IP and the access and who's allowed to look at what. A particular, so parochial, need of the DoD is, of course, classified information. And in particular, with dealing with AI systems, there is this concept that one fact may be classified or have one level of classification, including unclassified open. Second piece of information may be unclassified open, but if you put the two pieces together, now that's restricted. And so, especially if these models are being trained, they don't know that they can look at one, can look at the other, but they can't come up with a result that somehow combine them. I'm curious if you've had any thoughts on that, again, related to some of the IP issues.
So I want to backtrack for a second to set this up. In the early days, the conviction was the way to give AI's knowledge of your code was to fine tune them on your software. So they would take a model and then they would feed it your code and train the model to predict next token all the way through your software base. That we never viewed as a good technique. First of all, models don't memorize all the facts, right? It's like they'll come up with certain insights, but they still need to refer back to the code if they're doing something with it. So fine-tuning on customer code doesn't solve your problem. Second, it's really expensive, right? If you want your AI to be current, every time you check in a change or pull a branch, you have to re-fine-tune a model to make sure it's up to date, and that also doesn't make sense. And finally, there's the leaking IP. If you have any sort of sensitive code at all, you're nervous about fine-tuning a model on that code, even if it's supposedly dedicated just to you. You're always worried somebody's going to pay fast and loose with it. We have had much greater success using RAG, and I'll talk about. In fact, I think it comes up next. I'll talk about our architecture in a second, and I think that will answer the question. So you guys are much more expert in this than I am, but AI is definitely fueling an arms race on security, right? On both the offense and defensive side. There are new attack vectors coming from folks like Fancy Bear, where they're actually building agentic function into the threat. So if somebody falls for a phishing attack, it's not just a static piece of code, but a piece of code that can explore and has agency to try to do attacks. So I don't think organizations really have a choice. I think they've got to bring AI to bear in trying to better defend the kingdom. So here's the hope that we can all have the software of our wildest dreams and get there more easily. I want to cast this a little more specifically. With the emergence of agents, over the course of just this year, agents have become so profoundly better. We now believe we're in a position that we can automate much more of the software development lifecycle. AI started with sort of inner loop stuff, writing code, writing tests, writing documentation, but we're now seeing outer loop benefits, triaging a failure, doing a security review, upgrading patches, doing a simple migration, repairing a problem in the build cycle. These are all things that agents are increasingly capable of, and so we see this opportunity to bring agents to bear across the whole of the software development lifecycle. But another way to think about this is we want to make software engineering more fun. I mean, I loved to code in college. I mean, it was a blast, but we didn't have the work necessary to deliver a properly secured, hardened, easy to use product. I mean, that's where 90x% of the perspiration is. What if we could make that dramatically easier? And programming at large scale could be as fun as programming in the small. So that's my blind, stupid, optimistic view of where AI can bring us. Another funny aside, I've been called a blind, stupid optimist for many years. One of my buddies, we were having an argument back in the Java days And somebody challenged me and say, why would you think that would work? And I said, oh, I guess I'm just a blind, stupid optimist. One of my allies said, I hope you don't lose your optimism, Dietz, because then you're just blind and stupid. So if you like startups, this market is crazy fun. It started with vibe coding, where non-software developers could feed in a little natural language description of something fun, like a web page that plays tic-tac-toe, and lo and behold, out comes software that does that. There were a bunch of people that generalized from that and said, you know what? All the software we have should be tossed. Like, we're going to start over, and we're just going to feed in a natural language description, and out of is going to come a storage system or a network operating system. The AI will take care of everything. We always thought that was ludicrous, right? There is a colossal amount of value in the software that runs the world today. Not just implementation insights, but most software is ultimately spec'd by the code, right? And how it behaves. And so we set out from the outset to think, how can we capture, how can we mine the insights that are in the world's existing software and bring that to bear. We continue to believe that is going to be the sweet spot where for this marketplace. But it's AI has had this colossal growth period. It's really when Claude 3.5 launched last summer, it just had a quantum step up in its ability to deal with code that catalyzed this whole market. When we launched our agent inference cycles went from 0 to 97% of our workload in the first 10 days. So there was just this dramatic ramp in agents. I would say just now, with the launch of GPT-5, have we seen an agent model coming from another vendor, OpenAI, that is comparable to Claude. Up until now, Claude for Code has kind of had it's been a uniquely strong position. We certainly like there to be competition in that space. We do train a lot of our own models. We train models for RAG. We train models for completions and next edit. But these high-end agentic models that are able to go off and do these complex tasks, right now, we don't see anything close to Claude and GPT-5. On the open source side, it's probably Kimi K2 that is the closest to having agentic coding abilities. Again, the more the merrier from our perspective. It's good to have that competition taking place. So if you look at where this market is today, everybody's heard about AI. Most enterprise developers have tried it and experimented with it, but many of them have fallen off and don't see the kind of value, or at least their initial forays into it. We don't see the kind of penetration yet into the marketplace that you would expect, given this profoundly positive vision that I'm painting. And so it's indicative that these products need to get better before they're going to really sweep the market and take over. But there's a reason there's so much energy going into this market, because it's $1 trillion invested in software engineering salaries, and it's 45 million developers around the world. So there is for entrepreneurs, it's an incredibly exciting time. So a little bit about how we solve this problem of delivering knowledge of a large-scale software system. So we wanted to build a context engine. We saw RAG as the way to be able to deliver the right information to the models for the task at hand, but we needed it to be current. So we looked at the vector databases out there, and we didn't find anything that we thought could scale to every code change, every check-in, right? We don't want the AI not to know that you just added a new function to a class, right? We want the AI always to be current with what is running. And so we built this real-time vector database and a semantic map that we make an entire software system and supporting infrastructure, and then we use that. We have AI models that do semantic matches based on whatever it is that you're trying to do in order to feed exactly the right context in. And then we manage that context window. We're constantly compressing it, refreshing it, so that you never run out of context. With this, we've been able to deliver much deeper knowledge, understanding of complex code. So, there are a bunch of customers across the bottom that have tens of millions of lines of code that the other AIs throw up on and aren't able to handle. And so, clearly, I think this is the frontier that's really going to define how AI is brought to much more of the world's software developers. But if you want to go after the full software development lifecycle, you can't stay inside the IDE. IDE is a great place to look at code and review code changes, but people want to be able to bring their AI to bear in other contexts. So, for example, we now have cloud-side or server-side agents where we will spin up VMs that are compatible with your infrastructure, and we can write code, run tests, iterate in order to get the software right before coming back to the user. So originally, when you unplugged your laptop, your agent stopped working. Now you can have agents that continue to work. Like you can go home and have dinner with your family and then see what the agents were able to do for you on behalf. And this is, the model all our senior developers are using is they view themselves as a tech lead for a team of agents that they go off and employ. They can try a bunch of different approaches, right? The cost to experiment is dramatically less when you can have 4 or 5 agents working in parallel to try things out, and then they come back and then you can weigh those outcomes. The other thing that you need to have out of this is agents that are independent of specific developers. So we see agents that get triggered to do code reviews, or an agent that gets woken up if there is a failure to do triage, or an agent to troubleshoot a pipeline build failure, or look at a security exception. So we think they're going to be agents working with your software along with humans collaboratively. And so we want to be able to facilitate that. And I would say there was an earlier view of this market that said there's going to be special models that just do code reviews, or just do security audits, or just look at DevOps. We see the exact opposite. So there's a lot of hype out there. I wanted to try to separate a little bit of the marketing from reality. I do believe developers are becoming tech leads for agents that they want to spin off and go do work. But agents that don't understand your code base are really counterproductive, right? If you want an agent to be self-sufficient, then it needs to have the knowledge that you bring to bear on the software. And so this deep contextual knowledge, we think, is the key to unlocking the productivity of agents. They're described as magic, but they need supervision. We never, naive developers will often trust the code that the agent spits out. We strongly encourage people to be skeptical. Make the agent do the testing, make the agent try things out, and bring your human intelligence to bear in deciding what the right outcome is. Agents are also being pitched as replacements for software engineers. And we're a long way from that. They don't set up goals, right? They don't know, we need to move this application to the cloud, or we want to change to a microservices architecture, right? That human motivation is distinct, and they can't take on, I would say good rule of thumb, an hour or 2 task is the tops you can get out of an agent today. But that's up from, 5 minutes even 6 months ago. So they're getting better quickly, but you still have to decompose work into digestible chunks, or the agent will just get lost and flail. This context we talked about, I see opportunities to extend it in many other exciting directions. So through MCP now, a bunch of our partners are making their API documents, code samples available. So you can point Augment, for example, at Stripe, and we become a Stripe developer. Or at Redis, the CEO of Redis just did a podcast with us where he was enabling, Augment becomes an expert Redis developer. So like if you're taking on some new libraries, you can just point your AI at those libraries and you become expert much faster. This is one of the biggest impacts of AI. Anytime you're dealing with unfamiliar code, unfamiliar APIs, it helps you be productive so much more. All right, I'm going to wrap up. Here are my takeaways. In addition to this tremendous enthusiasm, I think AI is going to have the biggest impact on programming of any evolutionary step along our journey. I put it up against memory, open source, cloud. Pick your favorite. I think AI can do more to transform software and software engineering than anything else to date. But you've also got to keep it real. Agents can take on chunk-sized tasks, and that chunk size is growing, but humans are still absolutely essential to the process. The biggest boosts right now are accruing to the strongest engineers, or when you're dealing with unfamiliar code, you're new into a particular project. Getting huge returns on both ends of the spectrum. I think it up-levels everyone, but it's certainly not even. And last, I don't think we have any choice, right? I think the challenges for building secure software in this world are so high that we cannot live without having AI to bring to bear. Any other? Yes, questions?
Thank you so much for a great presentation. I had a question about the security. I guess the code assistants, they're great. I use them daily. They're amazing. But with the code assistant, you introduce another, I guess, attack vector, right? That they can be compromised as well. So if you have a malicious rules file, right, that you basically, a configuration file for your AI assistant, code assistant, it will potentially spit out code suggestions that are also have malicious pieces. I guess, can you speak about some of the challenges from the security standpoint that your company, is it like?
Yeah, so AI is of course just a tool, and it doesn't inherently, at least today, understand good security. So if you have great security practices in your code base, a tool like Augment will further those practices, right? It will protect them and preserve them. And if you set that up in policies in memory, will help. If you have an insecure code base, the same thing goes, right? It's like we will see patterns in the code base and assume that's what you want, and then we'll preserve it. But one of the things about these memories, and you need to have root privileges to set policies for a broader team, is you can change that. You can say, look, this was our old practice. Now we want to move to this new practice, and you can enshrine it in a company-wide policy that then the AI will try to push people toward. Now, right now, humans are still in charge, right? So humans make the ultimate decision of accepting, rejecting work from these various agents. So the AI is only so good as the developer that's making that final vote. But I would say that the other place where you can bring this to bear is you can have separate agents that are triggered on check-ins to do security policy reviews and then flag things. And in fact, those agents will look at all of the history of code reviews and say, we've seen this problem detected, and we want to be sure we're checking for it. So I think AI can bring, code reviews suck, right? And everybody's eyes glaze over when they're looking at somebody else's code. I mean, there aren't that many engineers that do really good code reviews. I think AI is going to do better code reviews than most humans, and will have the attention to detail to spot those challenges. So that's my hope.
I'm a tester, so I'd be interested in how do you go about testing these agents, right? Or do we see a day when we're going to be using AI agent to test another AI agent? And kind of related to that, in DoD, we're big on minimum viable product. Just ship it, right? Good enough. So I'm like, when it comes to AI agents, do you see that model applicable? Meaning you build an AI agent, it does good enough, but then when you upgrade that AI agent model, is that going to undo the work is done in the past? So I'm just curious about that concept, because everything is agile, even in DoD. But with like AI agents, I mean, do you have to have a perfect agent before you release it to the wild?
Yeah, so there's of course no perfect agent, just like there's no perfect human developer. They have failings too, but they're working against code and making it better. And we definitely have agents. You can have agents check the work of other agents. So I mentioned like having agents that are automatically triggered to do a security audit on new check-ins, or if there's an exception condition that's raised, you could have an agent that's doing that. We race agents routinely in development and say, look, there's a couple different implementation approaches I want to try. I'm not sure which one's better. You agent do this one, you agent do that one, and then I'm going to look at the outcome and look at the performance data and whether the tests pass. And by the way, keep working until the tests get passed. And then if one agent, doesn't do a great job, another agent can be launched to go in and look at it. And those agents are changing, with each new model release. They become a little more capable and so on, much like human engineers get better as they continue to work with a piece of software. Now, agents, I think, are getting better a lot faster. The open question is, how long is that going to continue, right? We're on this really crazy steep curve. I think at some point we're going to asymptote out, but it hasn't happened yet. So we're going to see what these LLMs are ultimately capable of in terms of how smart they can become.
Yes. Hey, thanks. This is a multi-part, broad, fun question. Okay. So I really like the part that I think your entire slide deck was sprinkled with a lot of positivity. And I think one of the quotes caught my interest. I think it was by Dijkstra. It said that software is something that you imagine with a specific structure, but it sort of maps to something in reality that it's not tangible. It's not verbatim, but I think that's what it tried to convey. It reminded me of how recently the sorting barrier was breached. They found a faster, shortest path, faster algorithm. That being said, that's the preface to the question, so it's a multi-part one. During a talk, you spoke about the return of investment of agents, right? So I see that a lot of AI agents are being used to figure out problems that we probably haven't really realized that they're problems by themselves. Like AI agents applied to, analyze two protein synthesis and find cures based on them. So when you apply these agents at the every level of the SDLC lifecycle, and I also noted that the augment code, one of the augment code agents also looks at the plans and specs and tries to figure out what to do based on that. So has augment code found a gap where they have identified requirements that were not perceived in the first place, and then that led to a large return of investment?
I'm not sure I've got the question.
The question being is, let's say you ran a bunch of agents through augment code, and then you are trying to fix tech debts, and address and bridge the various gaps. But then have you found out a problem statement that didn't exist in the first place, but then that led to a large ROI?
These agents really don't do well in ill-specified problems. Like if you give an agent a large code base and say, what sort of optimizations would you think, or how can I make this code more usable, or how should I evolve its architecture to make it more modern? They just flail, right? You've got to be much more prescriptive to get successful work out of agents in terms of giving them concrete, focused tasks. And oftentimes you've got to intervene. So we have tools like the agent's reporting on what it's trying, so that we hope that you'll see it and say, wait a minute, you're going off into the weeds. And redirect the agent in real time toward a more productive path. So I think we can get over time, I mean, this remains to be seen, toward agents that are much more capable as Uber architects that can handle these broader brush challenges. But at least LLMs today are nowhere near capable enough to do that. I'm not sure if that got enough of your question.
So I was wondering if we could translate an effort like that in the SDLC lifecycle. Maybe we figure out like we need a new feature, and that's something that's going to add a lot of value or something like that.
All of these areas, applicability for AI in chemistry and medicine and material science, the ability to explore many different design choices is incredibly exciting. Software, we have so many degrees of freedom, right? Arbitrary degrees of freedom. That's back to Dijkstra's quote, right? We're not constrained by the physical world. And I think this highlights a limit of these AI models is AI models today, other than like self-driving cars, they don't really have a sense for the real world, let alone the abstract world. And so if you try to have a dialogue with an AI about how data structures are being manipulated by code, they get lost pretty quickly. So they have a different skill set today, but I think that's going to change and evolve over time, and it's going to be just really fun to watch and have a front row seat for. Thank you so much for the opportunity to speak. Hope you have a great conference.